Alright, this book is going to become a book about angle pairs. You can see one that I've already created. So you want to title it on the front, Angle Pairs. You want to make sure you put your name on it. Since you do have colored pencils there, later if you want to decorate it, make it all pretty, you can. You don't have to though. So there's the cover for our book. I'm going to make mine boring. So if you're just writing this information on paper instead of in a little book, that's just the title of our notes today, Angle Pairs. We're actually doing section 1.7 in our book, okay? So if you're following along with what section of the book we're in, it's 1.7. 1.7, Angle Pairs. And please, please, please make sure you put your name on it because I always find these on the floor lost later. Okay. We are not going to fill in the whole book today. We're only going to do 4 pages, and then the last 3 pages will be our notes next time. Okay. The first 2 pages, you know, I'm going to do something different in this class than I've done in my other classes, and we're actually going to cram a couple of different things on the first page. The first page I want to review something really fast with you, and that is congruent angles. So I'm going to make you do a little bit more on this page than I made my other classes do. So you're going to have to squeeze some of this together. So what are congruent angles? Remind me. They have the same measurement, right? So we learned that on a different set of notes. So if we have an angle like that and an angle like that, but even though one has longer rays than the other one, as long as they're open the same amount, they would still be equal, and these little arcs mean that they're equal. And so let's pick a measurement that we think they might be. They look like they could be around 40 degrees, I don't know. So if they're both 40 degrees, are they congruent? Yes, they are. Okay, so that was just a little teeny review, congruent angles. Now we have something else we're going to learn. This one you were going to use once in a while. You need to know it once in a while, but this word is not as important to remember as the next one. So learn it, but make sure you actually learn the next one we're going to learn even better. Complementary angles. Complementary angles, the definition is 2 angles that add up to 90 degrees. 2 angles that add up to 90 degrees are called complementary angles. Let me show you a couple of examples of complementary angles. If we have a picture like this, and we know somehow that this is a 90-degree angle, like because it has a square in the corner, or maybe there's a square next to it, so that we also know that one's a square. We'll talk more about that later. And then that angle's been divided into 2 smaller angles. What do we automatically know about those 2 smaller angles? They add up to 90 because together those 2 smaller angles are forming the corner of a square, right? So this is one way of showing complementary angles, but they don't have to be adjacent like this. They can be totally separate. So we could have them separated, like maybe a 40-degree angle here and a 50-degree angle there. So they're not connected at all, but do they still add up to 90? Yeah, they do. So 40 plus 50 equals 90. That makes them complementary. Here, maybe I'll number these angles. Let's call that angle 1 and angle 2. So the measure of angle 1 plus, oops, I got ahead of myself, plus the measure of angle 2 equals 90. Okay, sometimes when we're dealing with complementary angles, we call an angle that's complementary to another one, we call it a complement. Okay, so For example, if I have an angle that's 35 degrees, what's the complement of 35 degrees? What's the complement of 35 degrees? What would I do? So I'm just going to kind of talk through some examples. I'm not writing these on the book, but I just want to write them down. Complement, you don't have to write them down, of 35 degrees. What would be the complement of 35 degrees? How would you figure that out? Complementary angles add up to 90. So if I have one of the numbers and I need to find its complement, how would I do that? 90 minus 35. So what's the complement of 35 degrees? 55 degrees. And what's the complement of 55 degrees? 35 degrees. Okay, so the complement of one angle is whatever angle it takes to make them add up to 90. Okay. Moving on to the next one that is the uber important one. Supplementary angles. Supplementary angles, this is the one you must remember. You're going to use this all year long. On the final at the end of the year, the CRT, there might be one question on complementary. But there will probably be 5 to 10 questions that use the word supplementary. It's much more important word to remember. Okay, supplementary angles are two angles, because this whole notes is about angle pairs of angles. Two angles that add up to 180 degrees. Two angles that add up to 180 degrees. Supplementary. So for example, we could have two angles just on a straight line like this. Like, let's call this angle 3 and angle 4. So what do we know about angles 3 and angle 4? The measure of angle 3 plus the measure of angle 4 adds up to what? 180, because they're on a straight line. And therefore they are supplementary angles. Okay? Now, do you think they have to be connected like this? Do they have to be adjacent like this? Nope. They can be completely separate angles again. So if we have one that's 40 degrees and a totally different one that's 140 over here, are those going to be supplementary angles? Yes, they are. How come? Because 40 plus 140 equals 180. So they are supplementary. Okay, so if I ask you for the supplement, what is the supplement of 35 degrees? We just kind of did this one with complements. I just didn't have room to really write it on my paper. What's the supplement of 35 degrees? How would we find that?
180 minus 35.
If we want to find the supplement of a number, we take the number 180, good, and we subtract the 35, which leaves us with what? 145. So 35 and 145 are supplements, right? 40 and 140 are supplements. In fact, if you look at a protractor, what do you notice about all the numbers lined up on a protractor? Notice anything strange about all the numbers that are lined up with each other on a protractor? They are all supplements. They all add up to 180. Okay? Alright, next page. No? Here's the same basic information. If I move on, I can leave that one there. Okay. Next is adjacent angles. Now we've already kind of learned about adjacent angles, so we're sort of just reviewing those. But actually we're talking about the specific adjacent angles that we would also call a linear pair. We actually already looked at a linear pair just barely because linear pairs are supplementary. So here's another picture of a linear pair after we define this really fast. A linear pair or adjacent angles, they share a side and a vertex. So adjacent angles share a side and a vertex. They form a straight line, like we just did with our supplementary angles. Remember this one that we drew that formed a straight line, and we said those are supplementary. So they form a line. And I've been saying this over and over. Adjacent angles, when they form a line like that, they're a linear pair, they are supplementary. So supplementary is a characteristic of adjacent angles that form a linear pair. So they're always going to add up to 180 degrees. That's going to be really important on our assignment today. Okay, let's look at some examples. Is everyone done with this page? Or I've got another one I can look at. I'll just leave that for now. Okay. So let's draw a picture of some adjacent angles. I don't know, we can call them whatever we want to call them. How about angle 5 and 6? So, notice how they share a side and they share a vertex. A vertex is the corner of the angles, right? They form a straight line. Okay? And because they form a straight line, they are supplementary. They add up to 180. So that the measure of angle 5 plus the measure of angle 6 adds up to 180. Now, do you remember with the word supplementary, it didn't matter if they were adjacent or not, it just mattered that they added up to 180? So supplementary is just a characteristic that this angle pair has. Because supplementary, they can be connected or not connected. But this type of angles must be connected. They must share that side like that. Okay? All right, last page. Last thing to learn about is called vertical angles. Vertical angles are formed by two intersecting lines. So just imagine two crossing lines, and that's how you end up getting vertical angles. They are across from each other. Vertical angles and adjacent angles are never the same thing. Vertical angles are never adjacent, although they do share a vertex. So I will put that. They share their vertex only. They don't share a side. Okay? And the important detail about vertical angles is that they are congruent. We already talked about that today. What does congruent mean? They have equal measurements, right? Okay, so let's draw a picture, a bigger one. That was just a quick example. Now, we usually think of the word vertical as being this direction, up and down. It doesn't have to be. Are those vertical angles up and down? Like here and here, is that a pair of vertical angles? Are they across from each other? Yes, and they share a vertex right there, right? But that's not the only pair of vertical angles in this picture. There's also another pair of vertical angles here and here, 3 and 4. That's another pair of vertical angles in the same picture. So 1 and 2 are vertical angles, and 3 and 4 are vertical angles, even though they're more horizontal. We don't call them horizontal angles. We still call them vertical angles because they fit this same definition. Okay, so that means angle 1 is congruent to angle 2. And angle 3 is congruent to angle 4 because all that set of angles is vertical and they're congruent, and that set of angles is vertical and they're congruent.